Welcome to the May 2020 CIECAST of ADAS Calibrations. Do it right and document what you do. I'm Ed Weidman, Executive Director of CIECA. The Collision Industry Electronic Commerce Association, or CIECA, develops and promotes electronic communication standards that allow the collision industry to be more efficient. We also provide webinars like this one to help educate both members and non-members. Today's presenter, Brent Johnson, is Director of Global Product Management for Collision at Chief Collision Technology, formerly Chief Automotive Technologies. Brent has degrees in both automation and business administration. He has more than 20 years experience in the collision repair industry. His career with Chief has focused mainly in R&D around vehicle data and information technologies. In his current role, he is responsible for all collision products, and the last 2 years has led the product development of Chief's Mosaic ADT, the industry's first automated ADAS calibration system, which uses OEM's tools, targets, and procedures. Today, Brent will be discussing the importance of providing a foundation for proper repairs and ADAS calibration procedures. He will also share best practices for repair record keeping and documentation. As we start the webinar, I want to remind you that there's no verbal communication between the participants and the presenter. If you have questions during the webinar, please type them in the webinar navigation page on your screen. We will answer as many questions as possible at the end of the presentation. And now, I'll turn the program over to Brent.
Thanks, Ed. And thank you all for joining me today. Given this weird time we live in, I hope you all are safe and healthy. So today I'd like to discuss ADAS, and the goals of this discussion are to provide an overview of why ADAS systems require calibration, the possible results of incorrect calibrations, why the use of OEM tools and procedures is a best practice, why documentation is necessary, and what documentation should be considered. Before I begin, I want to make sure everybody knows I am not a lawyer. I've never even played one on TV. Nothing in this presentation should be considered legal advice. Please consult a licensed legal professional if you have any questions about your specific business and what information you should be collecting and retaining in order to reduce any likelihood that some controversy is going to arise from your practices. I hope to provide some valuable advice. The recommendations in this presentation should provide a foundation for best practices. The views expressed in this presentation are my opinions only. Some definitions. ADAS is Advanced Driver Assisted Systems. During this presentation, I'm going to focus really only on those safety systems that are activated while you're driving down the street or driving down the road. There are some systems which do have a safety component, such as 360-degree view and automated parking systems, but mainly we're going to stick to the danger if you have an uncalibrated system going down the street. Static calibration is a calibration method that uses predefined targets, locations, and distances from the vehicle along with specific software to calibrate an ADAS. Dynamic calibration is a system that places the vehicle in a calibration mode, and then a driver drives a preset distance or time through hopefully a specific traffic density and with well-marked lanes. So why do we need to calibrate an ADAS system? Well, your ADAS system needs a real-world reference. It's akin to teaching a teenager how to drive. You can set a teenager loose with a vehicle and They will eventually learn to drive if they survive it, but they're going to run into a lot of stuff in the meantime. Your ADAS system is similar to that. It needs to know and understand what to consider a threat and what it can ignore. Your ADAS system, whether it's a radar or it's a visual system, actually sees a much bigger picture of the world as you're driving down the street than what it needs to respond to. It doesn't need to respond to parked vehicles or speed bumps. The system can see the speed bumps, and it has been known that it will slam on a brake. The automatic braking system will be activated if it picks up a speed bump, if it's improperly calibrated. Now, these things need to be avoided. So at distances that are needed for safety, small errors create big problems. So if you're going down the road at 35 miles an hour or 60 miles an hour or 80 miles an hour on the freeway, if you have a very small error, the system reacting improperly or failing to react will create a havoc on the road. All vehicles are calibrated in the factory using static calibration methods. Factories don't use dynamic calibration, even though some manufacturers require a dynamic calibration. They're only static calibrated in the factories. So this gives the vehicles, as they're coming off the production line, a real world reference. Most systems do have artificial intelligence. They do learn. So can you just leave them and let the AI learn? Yes, but unfortunately, like your teenager driving, it's going to take them a while to pick up what they should and should not ignore. So after a repair or a glass install, these vehicles need to be calibrated. This is an example from Brent Porter Group of a factory ADAS calibration system. What this system does is it characterizes the vehicle, it positions the vehicle, it determines the vehicle's thrust angle, the wheel run out, it positions the target automatically, and then through the ADAS, or through the OBD2 system, it communicates with the ADAS modules and performs a calibration. This is all done in about 90 seconds in a factory. These are two examples of Brent Porter equipment that's in factories. They have factories throughout the world, and they're in every major vehicle manufacturer and most vehicle manufacturers worldwide. So this system on the left is a gantry-based system. It's standalone. It's at the end of major factories. So again, it centers the vehicle, provides a rigid target on a stable gantry. They're forward facing and 360-degree calibration, and it's a drive-through system. On the right-hand side, that's essentially performs the same exact functions, but it's a compact standalone. It's not used in as high a volume factories. So why did they calibrate a vehicle in the factory and after a repair needs to be done? Well, 1 degree of offset at 100 meters will create 1.75 meters of error. And you can see from the thrust angle in this example, 1 degree of error at 100 meters is 1.75 meters, or about 6 feet. So there are very few vehicles that are wider than 6 feet, and none of them, except for wide loads, are going to be wider from the center line than 6 feet. So if the vehicle is not going down the road straight, and this is why we worry about thrust angle, and you can see on the lower right hand corner, a vehicle not going down the road straight, if you just use physical alignment on the ADAS system, it's going to miss that vehicle until it gets much closer. So at 65 miles an hour, at 80 miles an hour, this system is going to fail to apply the automatic emergency braking. So when should the ADAS be calibrated? If a sensor or control module has been replaced or reoriented. Most of these vehicles, with the exception of a few manufacturers, do not have the capability to adjust sensors. Some of these sensors are placed behind cosmetic panels. Some of them are on the structure of the vehicle. But if a sensor is behind a windshield, a panel, or a fascia that has been repaired or replaced, your system is going to need to be calibrated. If a vehicle has sustained structural or suspension damage and that damage has been repaired, you're going to need to perform a calibration. You need to tell the sensors where to be looking when they're going down the road. You need to let them know what is important and what they can ignore. So the use of OEM calibration tools. I know this is a bit of a controversy. It's also a bit of a real strain on shops. The OEMs have not made it easy to use their calibration procedures and tools. They bury their calibration procedures in the manuals, places where you don't expect them. They're not properly labeled sometimes. They take a great deal of effort and time to find. Then you have to read them and understand them. The issue with not using the OEM procedure, though, is you run into a situation where if something should happen subsequent to the repair and the calibration or lack of calibration, then are you going to be responsible for that liability? If you use the OEM tool and the OEM calibration, you're most likely going to have the best defense in that situation. No OEM that I know of, that I've heard of, approves an aftermarket tool for calibration. There's reasons for this. Some of them are commercial, but a lot of them are also technical. So you need to use an OEM tool. They're the most up-to-date, they're the most reliable, and they reduce the risk of liability. Obviously, a lot of these tools are very expensive. They're not easy to get. You have to be part of programs. However, there are remote options available. These remote options will come to your site and perform a calibration. They will do it over the internet. So you do have access to OEM calibration tools, although it's not easy. I know the insurance industry is not consistent on whether they will pay for these services. That needs to be fixed. But as we go through this, I think it needs to be stressed that you should rely on OEM tools. To be completely open, Chief does have a relationship with Aztec, and this, the test I'm going to reference here is from Aztec. I know the people that perform these tests. I trust their results. However, you may get different results yourself. They conducted a test over a year. They tested over 45,000 vehicles, and I'll show you the results in the next slide, but this one is from Nissan. The Nissan tool reported back that there was 27 modules in this particular vehicle, and I'm not sure what vehicle this one is referring to. Aftermarket tool A only found 17. Aftermarket tool B found 11. Aftermarket tool C found 21. So at best, there were still 6 modules that were missed by aftermarket tools. here are the more detailed results. This test happened during the year 2018, so we only have a small sample size for the model year 2019 vehicles. But for 2019, 87.6% of the vehicles that they tested, 345 out of 394, had safety modules that did not communicate with aftermarket tools. Now, this was one specific tool. I don't know what brand it is, but it's a major aftermarket tool. 2018, 31.2% of the modules failed to communicate. So if you have a vehicle that's 2016 or newer, you can expect a certain percentage of the modules that you're trying to calibrate, that you need to calibrate, may not respond with your tool. This is why it's critical to use an OEM tool. If you have a forward-facing camera or an automatic emergency braking system that cannot be calibrated by the tool you're using, you're not accomplishing what needs to be accomplished. That vehicle will not respond properly in a situation on the street after it's been repaired. So if you're going to do a calibration and you're going to perform it properly using OEM procedures and OEM equipment, you're going to need to maintain that data. Again, this is a situation where there's an awful lot of data that needs to be stored. Most of it you're already probably storing anyway. You're recording it, and some of this will be recorded by your estimating program or your shop management program or some other program that you already have. So, but as you're doing this, you need to maintain these files, this data, so that should something happen in the future, you can reference them back. So as Dan Risley, Vice President of Quality Repair and Market from CCC, said in the 2020 crash course, which is, by the way, it's free from CCC, and it's got a lot of great information. So you can log on to their website and search for crash course, and you'll come up with it, and it's free, and I'm sure they'd welcome you reading that. But as Dan put it, you need to document who performed repairs on the vehicle. Identify the technician who performed the scanning and calibrations. And by the way, this shouldn't just be for calibration of ADAS systems or calibration of any systems, but also your repairs. You want to know who the technician is that performed the repairs. Also, Dan didn't list it here, but you also want to know what their training level is. So you should be keeping records on your technicians, what they were trained on, and when they were trained on those procedures. So should something happen in the future, you can refer back to them and say, no, my technician went through the Toyota aluminum welding certification program, and he did it on this date. So the repair was performed after that date, so you know that technician was properly trained. So as Dan says, identify the technician who performed section and weld, whoever performed any structural repairs. The next W, what repairs were completed. Capture images of all the work performed throughout the repair process. Document the quality control procedures and identification as to who verified the quality. Again, this is imperative. You want to have quality control procedures, and you want to identify who did it and how they did it. When were the repairs completed? Document when or if pre and post repair scanning was performed. Both of these should be performed. You need the pre-scan and the post-scan. You need to know what error codes were present. You want to know if it's something that you choose not to repair, if it's say a mass airflow sensor or something that's has nothing to do with the collision and has nothing to do with your ADAS system, you can probably ignore it as you're doing the calibration. But you want to know if there's an error code that could affect your calibration procedure. You want a pre-scan before you actually start doing any repairs, whether they involve an ADAS system or not, because welders, electrical noise, things in the shop can damage the internal electronics of the vehicle. So if you have a pre-scan that says these are the error codes before we started the repair, the same error codes exist after we did the repair, we're not responsible for them. Document dates and timestamps of the repair. You want to know what was done when. Where were the repairs completed? Identify the location of the sectioning performed, identify welds, welding and or bonding procedures and locations. So I'm going to expand on this just a little bit. You want to know these locations, as Dan specified. You also want to know if there were any ADAS system repairs, where those ADAS units were located when they were repaired. But also, if you have to have off-site work done, that would fall under where the repair was completed. So if you send it out to be aligned, you want to make sure that you document who did the alignment. You want to document if you had to send it out to get the ADAS calibrated. If you don't have that capability yourself and you send it to a dealership, make sure you record that. And then why were specific repairs completed or not performed. The not performed is very important. Document what did or did not happen in the collision that you're repairing or the glass that you're repairing, and then document your decision-making process. Why did you exclude unrelated damage that was not repaired? You know, what brought you to the conclusion that this did not happen during the collision that you're assigned to repair? And then to expand on what Dan has said, the items don't need to be stored in a single location. They just need to be easily retrievable. So, you know, we're talking about retaining records in the unlikely event that something's going to happen and this vehicle is going to come back and you're going to need to perform another repair, or you're going to be accused of not performing the repair properly. So this should be a very unlikely event. So you don't need to create massive paper files or massive files on your server. You just need to know where this information is, and you need to have a system so that should something happen, you can have access to it and you can compile it easily and quickly without, it's a stressful situation already. Don't make it more stressful by having to dig through and try to find information that's stored in some back room somewhere. So back to the calibration data. Again, make sure that you have the detailed vehicle information being repaired. The technician training, I mentioned it earlier. Did the calibration technician have specialized training? Right now, ADAS training is somewhat sparse. I know there are some manufacturers that do a fairly good job of providing ADAS training and some that don't have much at all. And that's across the board. There are some programs, Toyota, Honda, Ford, some of these manufacturers have very good training programs for repair technicians. Some don't have very little training. So document what training was provided. Did they attend a technical school? Did they graduate? Do they have specialized training through that technical school? Again, what repairs were done to the vehicle, and specific to ADAS, did you need structural repairs? Structural repairs affect pretty much all the sensors in a vehicle, because they're going to affect the mounting locations, whether it's mounted behind a cosmetic panel, the front fascia, or it's mounted directly to the structure. Depending on the severity of the structural damage, you could have major misalignment or major repairs to all the systems. Did you perform a four-wheel alignment? Some vehicle manufacturers require, if you're doing a calibration, you have to have a four-wheel alignment. Some don't. But going back to the example with the thrust angle, that's imperative to know that you're getting a thrust angle. And one knock that I do have against a lot of the OEM calibration procedures is you're taking your measurements off of the body of the vehicle. It's not the suspension. So if the manufacturer requires a four-wheel alignment, then perform a four-wheel alignment before you do your calibration. And some manufacturers also require that you do a calibration after you've done a four-wheel alignment. So if you've been in a repair where there was damage to the suspension and you've had to replace suspension parts and you've had to complete a four-wheel alignment, you may have to do a complete calibration. Again, anytime that a vehicle has sustained suspension damage, you need to do a calibration anyway. So as you're doing these, record what was done, and then also make sure you know how to locate any reports created by the repair equipment. If you're using an electronic measuring system for your structural repairs, make sure you know where if it's stored on a server, make sure you know where that information is stored. If it's in paper form, make sure that you know where it's stored with that repair. Again, with your alignment equipment, make sure you know where that report is stored. And then again, note any sensors that were replaced or relocated, or if their mounting location had to be repaired, make special note of it. This one is a little bit more difficult. When you're doing the calibration, document the tool used for the calibration, including the software version. If you maintain and keep your tools up to date, the software up to date, then maintain those records as well. So part of your quality control procedures should include making sure that your calibration tool software is up to date, and then document when those updates happened, document what software version you were using. It's a headache to maintain this stuff, but it could save you a great deal of grief in the future if you can prove that or you had documented that you were using the current software version at the time that the calibration took place. So also store the procedure used. So there is a calibration procedure, a written calibration procedure from the vehicle manufacturer. Make sure you document. You don't have to print out the procedure and store it in a paper file. You certainly can if you would like, but make sure that you know what procedure was used. The manufacturers will update these procedures and don't always notify you when those procedures were updated. So make sure you check in advance that you've got the proper procedure. Then not listed on the file or on the slide, but if you're doing a dynamic calibration, you need to know who did the test drive. And some of the static calibrations also require a test drive after the calibration. So you need to know who performed the test drive, what course they took. You know, it doesn't have to be extremely detailed, but you want to know what major streets that they were driven on, what tool was used, what version of the software again, what quality control procedures were used, and what software is, you know, how you performed your version control. So I know I've covered an awful lot of information here in a fairly short period of time. I probably went through this a little bit faster than I wanted to, but hopefully this provides you a basic grounding of why you need to use the OEM procedures and the OEM tools. I know there's a lot of tools out there that claim they can do it, and they may be very good. They may be just as good as the OEM procedures, but if you don't have an OEM backing you up, if you don't have Ford or Toyota or Honda saying, yes, this is how you should have done it, then who will back you up? And that's the big question, is you need something to fall back on if you get into a situation that you don't want to be in. And I know everybody in this industry wants to do the best repairs they can. They want to make sure that the vehicle is safe when it gets back out on the road. And these OEMs, you've seen the commercials, they're advertising that they will stop for the drivers. They will perform emergency maneuvers for the drivers. People are starting to rely on these things. Whether that's right or wrong is up for debate. I think a person should be responsible for the vehicle if they're driving. But as our customers, the drivers, become used to these things acting in a specific manner, these ADAS systems acting in a specific manner, making up for their failures as they're driving, and then they get in a collision, you know, somebody hits them, or they just simply have to have their windshield replaced. If that system does not react the way that they expect it to the next time, something really bad could happen. And I know nobody wants that. So following the proper procedures, making sure that you're covering yourself, as unfortunate as that has to be in these times, but making sure that you take care of providing the information that you need so that should you become entangled in one of these situations, you've got this information available. So at this time, my presentation is done. Hopefully I did provide you some good information, and I'll turn it back over to Ed.
Thank you very much, Brent. Stacy Phillips, CIECA's marketing director, has been monitoring the webinar for questions. Stacy, have we received any questions from the attendees?
Yeah, we have received a couple, and although we're not able to comment on specific brands or manufacturers, we have had questions about how to confirm if a proper calibration was done. And Brent, we were wondering if you could please share any comments.
Wow, that is a great question. And unfortunately, the answer is you can't. There is none of these tools will tell you, or none that I know of, and I'm familiar with the vast majority of the major brands out there, whether they're in North America or actually worldwide. They will report that the calibration was completed, and they may say that the calibration was successful, but you don't know, they can't tell you whether it was performed in the right way. So if you have a target that's off center line, and the system could calibrate to it, and it will report that it was done properly, but you don't know that. So that's why a lot of the manufacturers do require a test drive, and why I would strongly recommend that a test drive be performed after any of these calibrations. But a lot of the tools will just finish. They will not report whether it was done or correctly or not. They just move on to the next screen, which is somewhat alarming.
Okay, thank you. We have another question asking, is a four-wheel alignment required every time before the ADAS is calibrated?
Depends on the manufacturer. I would say about 30% of manufacturers do require it as part of a calibration. So about 60%, 70% don't require it. But if you have any doubt about whether the thrust angle has been knocked out of proper alignment, you should probably do a front wheel alignment. But it depends on the manufacturer, which again is why it's important to understand what the manufacturer's procedures are.
Okay, thank you. And also, we were wondering approximately how many vehicles on the road in the United States are fitted with ADAS systems, if that's something you can approximate.
Last I knew it was in the low 20%, but virtually, I'd say about 80% of all new cars sold today on the new car lots probably have some form of ADAS, if not higher. And then by September of 2021, all major manufacturers in the United States have stated voluntarily that they will have automatic emergency braking standard on all of their cars. So very shortly, it's going to be 100%. But right now, for general population, it's around 20% because the average age of vehicles on the road are about 11 years. And we didn't see widespread acceptance until about 2016 for ADAS systems. But about 80% of new cars today at least have some form of ADAS on them.
Okay, thank you. And we're wondering if you're able to please share the year, make, and model options of the Nissan that was scanned on your comparison slide.
I don't have that available. I can contact Aztec and see if they can get that for me.
Okay, thank you. And we also have a question, what is the area required for a general ADAS static calibration bay, the length and the width?
Wow, that's another great question. Unfortunately, there are wide variations between manufacturers. Not to pick on anybody, but the Honda Odyssey and one of the Mazdas, the CXs, I don't know if it's the 6 or the 9, require 7 meters, 6 or 7 meters from your vision target. So you're looking at some fairly significant space. Now, if you're not doing a significant number of vehicles in that range, then you might be able to use part of your alleyway in your shop to back those vehicles off. The radar, some of them require wide open space in front of them. However, there is radar absorbing material that you can use to wrap some of the posts and some of the metallic objects that may be reflecting radar. But that's kind of really hit and miss, so I'm not necessarily recommending that. So again, you need to refer to the OEM procedures of the brands that you're handling most, because some of the Hyundais are right almost up against the vision target, and as I said, some of the other brands can be several meters back.
Thank you, Brent. With a windshield replacement, do you have any tips on how to verify that the glass repairer is equipped? You need to ask them, because they will need to do it. If you've got forward-facing cameras, the vast majority of them do fire through the windshield. Some of the windshield glasses have some problems. That's essentially a lens, so they can create some issues with the calibration. But most of the time, if they're creating an issue with the calibration will fail. So you'll just have to be diligent in asking whomever is doing the windshield replacement, do they have the proper equipment? Are they using OEM tools and procedures? That sort of information. Okay, and this question follows the previous one. After the windshield has been replaced and the on-site vendor calibrates the ADAS systems, is the vehicle still in need of an OEM calibration?
Hopefully no. If they use the OEM procedures for the forward-facing camera, and there has been rumors that a lot of radars are going to be moved to the windshield because radar modules are reasonably expensive, and being right behind the front fascia, minor accidents can damage them. So the insurance industry is pushing the OEMs to better protect them, but which is once again why you need to keep up on your OEM procedures and why you should be using the OEM procedure, so you know that that was calibrated the first time, that time, so you don't need to go back and have it done again.
And would you say there are any differences in calibration techniques with cars, SUVs, and heavy commercial vehicles?
Yes, there are significant differences, but it's more not necessarily to the manufacturer of the vehicle, but the manufacturer of the ADAS modules, whether it's a Continental or a Bosch or a Teledyne. The procedures change. So you could be doing a Nissan Altima and then do a Nissan Rogue, and if it's got a different manufacturer for the ADAS sensors, you may have a completely different calibration procedure. Now, most of the time that's not terribly common, and I'm not picking on Nissan. They may have exactly the same procedures across the line, but there's a lot of differences between ADAS procedures, not just throughout the different sizes and types of vehicles, but what the accessories are, what is going on with the or who the manufacturer was of the ADAS equipment itself, not necessarily the vehicle brand.
And how long do you think it will be before cars self-diagnose calibrations?
You know, I think that's quite a ways off. We'd been, just a few years ago, it had been prophesized that we would be having self-driving vehicles already, and the technology just is not there. So personally, and this is just my personal opinion, I think it's a little bit further off than what a lot of us would guess at this point. Whether that's 10 years or 7 years, it's not going to happen in the next 3 or 4 years. I just don't see that happening.
Thank you. And how much time would you say is saved with an ADAS calibration system versus using hand tools to calibrate?
It depends on the system you're using, and it depends on if you're doing a single forward-facing camera. There's a lot of setup involved. You need to know that the proper tire sizes, the air pressure, it's down to how much fuel is in the gas tank. All of that it doesn't matter whether you're using an aftermarket system or you're using the string and plumb bob method from the OEMs. That all has to be done. So the real-time savings come in when you start getting multiple systems, so where you're doing a forward-facing camera, a forward-facing radar, and a blind spot monitor. Then you can get some real time savings of 50 to 70%, depending. Some manufacturers, their procedures are less complicated than others.
And is there any advice you can give as far as talking to insurance partners regarding the different procedures and documentation?
That's another really difficult subject. If it was me, and I can say this because I don't own a shop. My uncle did, but I don't. I would, if an insurance company doesn't want to pay for a proper procedure to be done, or doesn't feel that they need to pay for specific aspects, I would ask them to sign a waiver, and then also show that to the driver and say, your insurance company doesn't want to pay for this. And I know that maintaining all these records is really putting a strain on shops. They've got more than enough work to do, and a lot of it the insurance companies just rack up to cost of doing business. So it becomes a really difficult argument, and I really wish I had a good answer, but I don't.
Thank you, Brent. A body shop owner has asked, he's trying to limit his sublets, and he wondered if all calibration should be sent to a dealer, if that was necessary.
You know, if you've got a really good relationship with a really good dealer and they're efficient with it and they're helping you with your cycle times, subletting it is not necessarily a bad thing. But whenever you give up control of that vehicle, then you find yourself at the mercy of some other business. And you know, that's just, again, it's not something that I can give one answer across the board. It really depends on your relationships, and if that's a great dealer to deal with and they pay attention to your cycle times and they're willing to help you out, by all means take advantage of that. You know, save yourself some overhead if you can. But if you're struggling with it and your cycle times and you're losing control of the vehicle, then you're going to have to make a business decision on which is going to be more costly for you.
And how does a consumer know if his or her car is not calibrated, if there's no light?
If it's really out of calibration and you've got lane departure warning, one of the ladies in our company, her lane departure warning was going off all the time when she was going straight down the road. So it depends on how bad it is, but the driver will know it. I think it was always trying to correct her, and she was fighting it all the time, and it was very frustrating for her. And she didn't, until we started working with ADAS, she didn't understand what was going on. And you know, it's frightening, but it just depends on the vehicle and what ADAS functions are on there. If it's something like automatic emergency braking, if it's braking too soon, you're going to know it. Or if it starts braking on inanimate objects outside of your lane, you're going to know it. But if it's braking too late, unfortunately, what you're going to find out is it's not going to brake when you need it. And so it's not always obvious. Sometimes it's extremely obvious. Sometimes it's not.
And can you please talk about thrust angle problems, if they need to be corrected, not compensated for with an alignment?
It depends on the severity of your thrust angle. If you're off several degrees, you're going, you know, obviously there's a suspension problem. There's something that's bent in your suspension. You're going to have to replace it. You're going to have to correct it. So at that point, if you're a collision shop and you don't have that kind of expertise, you may have to go to a specialty suspension shop or a suspension shop and let them take a look at it. So again, it comes down to severity. The calibration system will compensate to a certain degree, but there will be a time where it's just not able to compensate for it.
Okay. And is there a website or another place that you can recommend that lists all the vehicles with ADAS?
No. When we were starting our project, we ended up having to spend an awful lot of money on a study to get that information. So I have not found any place where it's readily available. Okay.
And how can someone tell what ADAS equipment is on the vehicle?
Again, a great question. It's not, you're not going to find it in any VIN code. Again, that's something we spent quite a bit of time and effort trying to determine. So far, we've not found a VIN code system that will tell you to that level. So the best way to do it is using an OEM scan tool, and it'll tell you what modules are on there. Unfortunately, if a module is so severely damaged that it doesn't respond, it may come down to just inspecting the vehicle and seeing does it have lane departure warning, does it have a radar system. And you can go to the vehicle manufacturer's website and find out what's available for that vehicle, and then start working through a process of elimination. But short of that, I don't have a good answer. Again, that's something that really is needed in the industry, and we just don't have that.
And we've touched on a little bit, but is there required lighting for all vehicles?
There, again, it's part of the OEM procedures. There is a maximum and minimum amount of light that is required during a visual camera calibration. So again, there's a lot of minutia in these procedures. So you know, if you've got too much ambient light, or you're trying to set your targets up in front of a window with the sun coming through, it either will fail or it's just not going to work properly.
Okay, and what is the difference between radar and LiDAR?
Radar and LiDAR are very similar in their theory of operation. Radar uses radio waves. That's the first R in radar. Radio direction and range finding. LiDAR uses lasers, so it's either visible or generally infrared light that is transmitted, as opposed to radio signals. It's a higher frequency.
Okay, and can calibration be done on an alignment rack or on the floor?
Both. It can be done on an alignment rack if you've got space for it. Most of the OEM procedures say on the floor, but any flat surface will work. Now, what gets complicated on a rack is if you're doing 360, you have to lay mats around the vehicle that stitch together the 360-degree camera. But some of that can actually be done from inside the vehicle, and you don't really need a special calibration tool to do that on a lot of manufacturers, which is one of the reasons why I didn't specifically speak to that.
And going back to LiDAR, do you have to calibrate LiDAR?
Yes. LiDAR is...
And we have time. Go ahead.
Go ahead. LiDAR requires calibration as well.
Okay, thank you. We have quite a few questions. We have time for a couple of more, and the ones that are not answered, Brent has kindly offered to answer them, and we'll post them on the website as well. But what are the advantages and disadvantages of using a third party for calibrations versus doing them in-house?
Well, the advantages are you may have economies of scale. So if there's a third party that specializes in calibrations, they may be able to turn them much faster. They may have access to more complete OEM equipment, and they accept the liability for the calibration. The disadvantages are, as I stated earlier, you lose control of the vehicle. You're relying on the quality of work from somebody else that you can't really control, and you lose the ability to control your cycle time. There's probably others, but those are the big ones I can think of right now.
Okay, thank you, Brent. There are quite a few more questions, and we'll share them with you and post the answers on the CIECA website. So thank you for taking the time to ask them.
Thank you very much. I'd like to thank everyone for taking the time out of their busy schedule to listen to me today, and hopefully I provided a little bit of value to your time.
Thank you, Brent, and thank you, Stacy. Hey, please be advised that CIECA does not endorse any company or product. Any company or product mentioned during this presentation was used solely for illustration purposes. Questions also that were submitted regarding a specific product or manufacturer could not be answered during the webinar. Don't forget to check CIECA.com for a full schedule of future broadcasts and to watch recordings of past webinars. Links are available under the CIECAST tab at the top of the page. CIECA has partnered with the Automotive Management Institute. Attendees of this webinar are eligible to receive credit toward a professional designation from AMI after taking a short quiz on its website. A link will be provided to all attendees after the webinar. Please follow CIECA's social media platforms to stay up to date on upcoming events and CIECA news. This concludes today's webinar.
Thank you very much.